Hello, algebra students. We're going to spend another day today talking about solving absolute value equations. In our last lesson, all of the equations just had one step once we got the absolute value into two different equations to solve. And we'll start like that today, but we'll be going a little bit beyond that. So when I see an equation like this is just like in our last lesson. So the absolute value of x plus 1 is equal to 6. I would start by saying that x plus 1 stuff, that's 6 units away from 0. So it's either at positive 6 or at negative 6 in the number line, which means I could write two equations. So x plus 1 is equal to 6, or my other option is x plus 1 is equal to negative 6. And then we just solve this. Again, this is just one step. So to get rid of adding 1, I would subtract 1. And I'll get that x equals 5. Or on this one, when I subtract 1, you may want to do a keep, change. So I'm going to get that x equals negative 7. And then remember, you can check this. If x is 5, we could put it in right here. 5 plus 1 is 6, and the absolute value of 6. If I put in a negative 7 plus 1 would be negative 6, but the absolute value is positive 6, so that works. Again, just like yesterday, if I had this absolute value equation, I could start by saying, well, then either negative 3x is equal to 30, or the other option that I have is that negative 3x is equal to negative 30. When I solve this, I divide by negative 3 on each side. This answer is going to be a negative 10. Over here, when I divide by negative 3, because they're the same signs, I'm going to get that x is positive 10. And again, I could check this. If I would substitute for that x, negative 3 times a negative 10 from my first answer, that'd be positive 30, and the absolute value is 30. Or negative 3 times positive 10 would be negative 30. But again, the absolute value is still going to be 30. Now I want you to notice that I've got more stuff in the absolute value. So I'm going to have to write my two equations, but I'm going to start exactly like I did in the last lesson. So I'm going to write my absolute value stuff equals 3, or it equals negative 3. So two equations that look very similar. Or 6x plus 9 equals negative 3. When I solve this, you know that the 6 is attached to the variable, so we'll leave that alone. I would start by subtracting 9. Whoops, sorry about that. So 6x equals negative 6. And in the second equation, sorry, I don't know why that box didn't go away. If I subtract 9 from both sides, I'm going to get that 6x equals negative 12. Now, I know that I didn't solve either one of these, but I wanted to start this one to show you I'm getting very different answers, just like I did with the one-step equations. I just still have another step to do. So I'm going to get that x equals negative 1, or over here, x equals negative 2. I said negative 1, but I didn't write the negative. Both of these answers work. We can substitute them both in there to make sure, but I wanted you to notice that all of the steps are exactly the same in both problems. It's just that the numbers that I had it equal to in each problem were a little bit different. So again, if I check and I substitute in for that x, 6 times a negative 1 would be negative 6. I can write that down even. Negative 6 plus 9 is 3. And that the absolute value of that is equal to 3. If I put in a negative 2, 6 times negative 2 would be negative 12 plus 9. That would be a negative 3, but the absolute value of that is 3. I should have been keeping absolute value in all of those. In this problem, you know that we want to write two equations, right? I can't in this problem because there's no such thing as a negative 0. My equation is just going to be 5n minus 5 equals 0. Since there isn't a negative 0, I only get one answer in this problem. That's not typical. That's kind of a special case, but it can happen. So I'll have 5n equals 5 and n equals 1. And again, checking 5 times 1 is 5, and 5 minus 5 is 0, and the absolute value of 0 is 0. This is one of those trick problems. Now, it only looks like a one-step problem, but the fact that this is a negative number right there, I cannot have absolute value equal to a negative. There's no work to show. This is a no solution problem. This one, we have a couple of steps to do, and I can write my two separate equations. So my first equation would be negative 1 minus 8x equals 41. Or negative 1 minus 8x equals negative 41. I would suggest that we do a keep, change on each of those. And the negative 8 in both of these equations, that's what's attached to the x. So we want to leave that alone. So I would get rid of the negative 1 with a positive 1, or adding 1. So negative 8x equals 42. And some people right now are going to start freaking out and thinking that we did something wrong. And I'm going to say, sometimes we get fraction or decimal answers here. That's okay. So you could certainly just divide that, and 42 divided by 8 would be 5.25. This will be negative because they're two different signs. If you use a calculator and just divided, there's your answer. If you looked at this like just an improper fraction, I would say, well, 8 goes into 42 5 times, and there would be 2/8 left over, which would be negative 5 1/4. All of those answers mean exactly the same thing. When I solve the second equation, same steps. I'm going to add 1. But this time, negative 41 plus a positive 1 gives me a negative 40. That one's nicer. When I divide by negative 8, that's going to give me positive 5. So negative 5 1/4 and positive 5. And for our last problem, this is really just it looks like a one-step problem. It's a little bit more tricky though, because the subtraction has the n after that. So we'll start by writing our two equations. 10 minus n equals 12, or 10 minus n equals negative 12. That minus n part, again, that's the part that I have a little bit of a problem with. So I would want to do a keep, change, and I like to sneak a 1 in front of that variable. I should have left a little bit more space. But that's really a negative 1n in both of these. That means that the 10 is being added. I would have to subtract it to get rid of it. So I'll have negative 1n equals 2, and divide by negative 1. In my second equation, I would do the same thing and subtract the 10. So I have negative 1n equals, negative 12 plus a negative 10 is going to be a negative 22. And then divide by negative 1. So if I tried putting in my answers in for that n, I would have from this first one, 10 minus a negative 2 would be 10 plus 2, which is 12, and that's the absolute value would be 12. If I put in the 22, I would have 10 minus 22, that's negative 12, but the absolute value would also be 12. So today's assignment that you're going to work on for practice is the absolute value equations day 2 worksheet. Be really careful on that. Make sure you're writing 2 equations. Make sure you're solving both equations. Please don't try to take a shortcut and just write one equation and then go back and change just a sign. People make too many mistakes that way. When you're all done, make sure that you go to Schoology and take the formative. Let me know if you need any help.